Hello, how to solve this exponential problem? This is t to the power of t to the power of 4, and this equals 64. So we are solving for all values of t that satisfy this equation. Now, if you observe, we have 4 here at the exponent, and we need to take notice of that. Because we have 4 here, we are going to raise each part of this equation to the power of 4. I have t power t to the power of 4, and this is raised to the power of 4. And we also raise this other part to the power of 4. We have 64 to the power of 4. Now, let's consider this identity. If you have a power n raised to the power of n, this equals a power m raised to the power of n. So we are going to consider this t power 4 as a unit. This can represent our n, and this represents our n. So we are not going to apply this part of the identity in order to transform it. So we will have, if you consider this, the m, which is outside this now, is now inside the bracket. So that means this will come inside the bracket, and the n will then go outside the bracket. You consider this other part of the identity. So let's apply that. Remember, the t is still constant. This is the base. So we are simply going to have t, which is the base. Now the m is now inside the bracket. We have to the power of 4. And this is raised to the power of the n is now outside, t to the power of 4. And this equals 64 to the power of 4. So right now, the base and the exponent are the same. T power 4, we have t power 4 here. So what next we can do is to also ensure that the base here and the exponent here are the same. Here the base is 64, quite different from the exponent that is 4. So for us to achieve that, we are going to consider this 64 is a perfect square, which is a to the power of 2, right? And we will replace this 64 here with a to the power of 2. So what we are going to have will be, this is t to the power of 4 raised to the power of t to the power of 4, and this equals 64 here. We are going to replace it with a power 2, give a power 2 raised to the power of 4. So going by that, we can consider this other identity. You have a power n raised to the power of n. This equals a power n times n. We need to multiply this out. That will give us, we have t power 4 raised to the power of t power 4. And this equals 8 raised to the power of 2 times 4. That is 8. So at this particular point in time, we have t power 4 here, we have t power 4 here, we have 8, we have 8. So what we can do will be to consider this identity. If you have a power a, this equals b power b, that means a equals b. So we can easily say that t power 4 equals 8. So at this point, we can solve for t. And for us to solve for t, we need to eliminate this 4 here. And for us to achieve that, we can multiply this exponent by 1 over 4. Half t power 4 raised to the power of 1 over 4 equals 8 power 1 over 4. So the next thing we can do will be to consider this same identity again. If you have a power n raised to the power of n equals a power n times n. So we need to multiply this out. I will easily have t power 4 times 1, that is 4 over 4. And this equals 8 power 1 over 4. So if you consider 4 over 4, this will give you 1. So what we are having is simply t equals a power 1 over 4. Now, this is our answer. We can as well transform this. Remember, 8 is the same thing as writing 2 to the power of 3. That means 8 equals 2 times 2 times 2. 2 times 2, 4 times 2, 8. So we can replace this 8 here with this. So we simply have this is 2 power 3. That is for 8 raised to the power of 1 over 4. So from here we have t equals 2 power, this is 3 times 1. We have 3 over 4. We leave it this way. We can as well transform this again. Remember, if you have a power n over m, this equals the m root of a power n. We apply this identity here. You simply have t equals the 4th root of 2 power 3. And remember, 2 power 3 is 8, so we have the 4th root of 8. So this becomes our answer. Now, what we can do again will be to insert that particular value of t back here. And let's check if it's going to satisfy the equation. We have t equals, we have the first one as, we have this 4th root of 8. We also have 2 to the power of 3 over 4. So, and we also have a power 1 over 4. So these are the solutions. We can transform them to from this one to this one, from this one to this one. Now, let's insert it back here. We can consider inserting this. This is the simplest form. We have t power 4. And this equals 8. 8 is 64. I insert this for t. That means I'm going to have 2 power 3 over 4 raised to the power of 2 power 3 over 4 raised to the power of 4. And this equals 64. I consider this identity a power n raised to the power of n equals a power n times n. I multiply this out. That means 4 cancels 4 because 4 will multiply 3. That will give us 12. 12 divided by 4. That's 3. So we are going to have 3 left. You have 2 power 3 over 4 raised to the power of 2 power 3. And this equals 64. And remember, 2 power 3 is 8. This is 8. So we are simply going to have 2 power 3 over 4 raised to the power of 8 equals 64. And from here, this 8 multiplies 3. That is 24. So we have 2 power 24 divided by 4. This equals 64. 24 divided by 4 will give us 6. So we have 2 power 6 equals 64. Yes, obviously 2 power 6, that is 2 times 2 times 2 into 6 places. Will give you 64, and this equals 64. Left hand side equals right hand side, so that is it.